Okay, so this is the last equation we were able to get from the last video. Okay, this is equal to this, of course, bracket and continuous here, which is equation 12. Now, before we move to the next equation, remember we are trying to express the electric and then the magnetic field. Okay, we are trying to express them with this, the magnetic vector potential, and then the what? The scalar potential. Now, why are we trying to do this? Because it's easier to solve with this than to solve with this. Okay? How do we know it's easier? People years back tried it and found out that it's easier to do this. Okay? And of course, how did you even like came up with this? It was from this equation. Okay? From this equation, the coil of the magnetic field, magnetic flux intensity equals what? Zero. This is the equation out of the four equations of Maxwell. This is the one that gave them that move to begin to simplify. Okay, so of course, being that this is the only equation in Maxwell that equals to zero. Okay, so uh, now looking at equation 12, we can see that it is expressed in what? It's now expressed in A, which is the magnetic vector potential, and then in V, which is the scalar potential, and also in what? J, which is the source. Okay, the source current. What's leading to the electric and magnetic field? I think we have already explained source in a previous video. So let's continue. Now, since we have, oh, I should not wipe that out. I think I need this to be clear enough. Excuse me. Okay, so since we already have this, because look at this equation, what do we have? A. This is just this just mean this nabla it is an operator, vector operator on what? This. We have this, and all these guys, they are numbers. I know they are Greek letters, but they represent numbers. They will represent numbers. So, and this guy, the same as this, should have bar on top of it. Bar. Okay. And then of course, and then you see this, which is this. Let me put the S, JS. Okay. And then you see this, which is this. And then you see what? This, which is this. So the equation 12 contains these three. Okay. Now, remember, if we are able to derive, to get the value of this, which is this one, then we can now start addressing, get the value of this, then get the value of this. Then we can now address what? The electric and what? The magnetic field. Okay? When we say magnetic field, we can write this and we can also write this. I will say electric field, we can write this and we can also write this. This is for electric field intensity. This for electric flux density. This for magnetic field intensity. This for magnetic flux density. Okay? So electric, magnetic. All right. So now, starting with A, just A. Okay, leave the rest. Starting with just A. For you to be able to identify a field, what we need to know the coil and what? The divergence of the field. So we need to know the coil of A, and we need to know the what? Divergence of A. All right. Now looking at looking at we've already done something that has to do with the coil of A. Okay, if you look at our previous equations, we have done something that includes what? The coil of A. Okay, look at it here. Look at it here. So the coil of magnetic flux density equals to what? The coil of A. Okay, but do we have the same as equation 4? But do we have the divergence of A anywhere? No, we don't. I don't want to spend my time looking through it, but I know we've not done anything on the divergence of what? A. All right. But if you look at equation 12, you can see the divergence of A right here. So you can single that one out. You can single that one out and do and see what this guy. You see this place now? Just bring everything here out. So you have what? Divergence of A plus what? J omega E omega epsilon naught mu naught V. Now we've brought all this out and set them equal to what? 0. So we can now say, of course, move this to the other side. Simply speaking, so the divergence of A, which is the magnetic um, vector potential, will now be equal to what? Negative j omega epsilon naught mu naught V. This is what equation 13. Okay, so now we have what? The divergence. So we can now say this particular field is what? Defined. We can now define it just like what he said here. This specification of the divergence of the magnetic vector potential is referred to what? As the Lorentz condition. Okay, with Lorentz condition, we have completely specified A. Remember, I said that to completely define, or let me use the word specified because that's what we have in our notes. Okay, to completely specify any field, you need to know what? The coil and the what? Divergence, which we now have. The coil, we have it in equation 4 and 8. The divergence, we now have it in what? Equation 13. So this field is now what? Completely specified. Why do we need to know, to say a field is completely specified? We need to know the divergence and the coil. Why? Put that in the comment section if you know the answer. Okay? If you don't worry. We'll still check on it and do what? Put it in the comment section. But please do and put it in the comment section. Okay? Assignment. All right. Well, just know that we need to know those two for a field to be what? Specified. In fact, let's just say it, okay? To save, let's just say it. Remember, the divergence tells you field going, the lines of the field lines, if they are going in, like going from a source to what? Where it ends, like from beginning to an end. Beginning to an end. That's what divergence tells you. Okay? Whether it's going in or it's going out or it's not going anywhere. Like just straight. Okay, so like this, or the opposite like this, or like this. Okay, or just like this. Do you understand? So this one will now tell you something about the field. Then for coil, okay, so knowing this gives you a specification of the field. Then for coil is what? Rotation of the field. Okay, so if you know rotation of the field and their movements, at least you have things to you now know specifications of the field. Okay, all right, that's that. Shouldn't be part of this video, but that's so. Of course, when you make the research, to put them in the comment section. All right, so now we've said that. Now remember, okay, that this, look at this one now, equation 12. Can you see equation 12? Now if you put this, let's quickly do this. You see this thing now? Look at it here, right? That's what you have here, right? Same guy. If you take all this and place it here, Look at this thing carefully. You take all this and you place it here. This thing is negative and it's exactly the same as this. Are you following? This is positive, this is negative. They are both the same. You are using this one to replace this, meaning you now have negative this, positive this. Bringing this one, bringing this one here. I don't want to write the whole thing again, so this will be here. So negative this, which is what we have here now, plus this. That will be what? 0. The same thing, negative and positive, they'll do what? Cancel out. So you give you 0 there. Meaning equation 12 will now be what? Equation 12 will now be what? Everything you have here. Let me save time and just simply clean this whole stuff. So, that's okay. Meaning everything here will become 0, right? So, everything there will be 0. Okay? So, that's what you have there. Okay? Then, of course, what will you do now? You will do what? Write this as same what? Equation 14. Ta-da. Okay? So that's that. Okay? Hope that's clear. So we'll just stop this video right here. Any question, ask, like, share, subscribe, and I'll see you in the next one. Okay? Bye for now.